Hello everyone, we are the students of the second year Aeronautical Engineering ASTA. Now we are presenting the various processes of the thermodynamic cycles. There are number of cycles present in the thermodynamic processes like Otto cycle, Petrel cycle. Now I will present the first two processes of the Otto cycle.
I will explain another two processes of Otto cycle.
I will explain whole Carnot cycle. Cycle first, Otto cycle. Otto cycle describes operation of spark ignition internal combustion engine. Internal combustion engine, it is the engine in which combustion of fuel occurs internally in an engine with using the spark plug. Spark plug ignites the combustion inside the engine. There are mainly four steps involved in the Otto cycle, as namely process 1 suction, process 2 compression, process 3 expansion and process 4 exhaust. First process, intake process. This process is also called as the suction process. In this process, air comes from the outside into the cylinder. At this moment, piston is at downward, that is BDC, bottom dead center. Both the valves, that is intake valve and exhaust valve. Intake valve is open and exhaust valve is closed. It creates the vacuum in between the cylinder. The vacuum causes the increase in volume and also increase in temperature. Due to increment in volume and temperature, pressure will also increases. Second, compression process. In this process, the piston moves from BDC to TDC, that is piston moves upwards. In this process, the air and fuel mixture is compressed between the cylinder due to the movement of piston from downward to upward. There is small possibility to increment in the temperature. The air fuel mixture compresses, it causes the increases the pressure and also increase in temperature. Due to increment in pressure and temperature, the volume will decreases. This process is also known as the isentropic compression process. Isentropic compression process, it is the process in which the adiabatic process is occurs reversibility and causes compression. This is the compression process.
Hello everyone. So today I will be explaining the two processes, expansion and exhaust of the Otto cycle. Basically, Otto cycle is a thermodynamic cycle that describes the operation of a spark ignition internal combustion engine. So the expansion process. Uh, Here the spark plug is ignited and the inlet valve and out exhaust valve both are already closed. Now in this process the position of the piston is from TDC to BDC, that is the piston moves from top dead center to the bottom dead center. So while moving the piston, there is the decrease in the temperature and as well as pressure, so there is increase in the volume. This is also known as adiabatic process, means this is the adiabatic process. Now coming towards the exhaust process. Now in this process, this is the last step of any cycle. So here the inlet valve is already closed and exhaust valve opens. Now the position of this piston is from BDC to TDC, means the piston moves from bottom dead center to top dead center. Now while moving the piston, here the pressure decreases and as well as the temperature also gets decreased. Now it helps to push the combustible process to go outside, means the combustible process products goes outside the. So as we have seen the expansion and exhaust process, the above diagram shows the position of the piston with respect to its processes, and the this graph shows the PV diagram of the Otto cycle and its processes. Now for this we have to find the efficiency. Now for process 2 to 3 there is the Q inside, and for process 4 to 1 there is the Q outside, that is heat releases. Now for this Q inside formula is MCV T3 minus T2, and for Q out we have the formula MCV T4 minus T1. Now for finding the efficiency we have the formula Q1 minus Q2 by Q1. Now by rearranging this formula we get final efficiency is equal to 1 minus Q2 by Q1. Now substituting equation 2 in equation 4. By solving this equation we get the relation between all four temperatures, that is T4 by T1 is equal to T3 by T2. Now doing minus 1 at both sides, from this we get the relation, that is T4 minus T1 by T1 is equal to T3 minus T2 by T2. Now for this again we have to find the value of T1 by T2. Now by rearranging those values we get the value of T1 by T2 is equal to T4 minus T1 by T3 minus T2. For adiabatic process we have the relation T1 by T2 is equal to V2 by V1 raised to gamma minus 1. Now substituting equation 6, that is the value of T1 by T2 in equation 5th, we get efficiency as 1 minus T2 by T1. Now substituting equation 7 and in equation 8, that is value of efficiency, we get the final value of efficiency. Therefore the efficiency is equal to 1 minus 1 by Rk raised to gamma minus 1. Here the Rk is V1 by V2, that is volume of beginning of compression upon the volume of end of compression. So coming towards the conclusion, we have seen the two processes, expansion and exhaust, and the derivation of the efficiency value.
Today we are going to learn about the Carnot cycle. There are various types of the cycle in the thermodynamics: petrol cycle, diesel cycle, Otto cycle. So firstly we will learn exactly what is the Carnot engine is. Carnot engine is the theoretical engine which is free from all particle imperfection and cannot be realized in practice. It has the maximum efficiency and it is an ideal heat engine. So Carnot engine is works on the Carnot cycle. So Carnot cycle is the thermodynamic cycle that represent the most efficiency process possible for heat engine, as it has the maximum efficiency and all the heat supplied is converted into work done. Means we know about this equation Q is equal to W. So all heat converted into work done. So let's go the what is the PV diagram for the Carnot cycle. So in this PV diagram we show the PV diagram for this Carnot cycle. This is the PV diagram. PV diagram. So we can show A, B, C, D. This is point for this graph. So A to B is the isothermal expansion. In this process, its value will be decreases and pressure will be increases. And the second process is to B to C. So in this process, adiabatic. In this process is the volume will be increased, pressure will be increases, value will be decreases. Value will be decreased and Q is equal to 0. This process is called the adiabatic expansion. And third process is to C to D. This process is called the isothermal compression. And fourth one is the D to A. This is adiabatic compression. In this adiabatic compression, Q is equal to 0. Below this PV diagram, we can write the equation for the individual process. So we can first process is isothermal expansion. So Q is equal to RT1 ln V2 by V1, and the W will be RT1 ln V2 by V1. And the second process is adiabatic expansion. So adiabatic expansion is Q is equal to 0. So work done is CV T1 T3 minus T2. So CV means the specific heat at the constant value. And the third one is the 3 to 4. This means the C to D. This isothermal compression. So Q is equal to RT2 ln V4 minus V4 divided by V3, and the W we RT2 ln V4 by V3. So last one process is adiabatic compression. In this process is the Q is equal to 0, and work done will be minus CV T1 minus T2. T4. So specific CV means the specific heat at the constant value. So this equation. So let's go the derivation for the efficiency of the Carnot cycle. So let's go. We know about this. In this PV diagram, two curve will be adiabatic, and remaining will be isothermal expansion and isothermal compression will be. So in this adiabatic process, two equation we can right. First is for C to B is adiabatic process. So first equation for C to B. So T1 V2 raised to gamma minus 1, T2 V3 is gamma minus 1. So this equation arranged like this. T1 by T2 is equal to V3 by V2 raised to gamma minus 1. So second curve is adiabatic for D to A. So equation like this: T1 V1 raised to gamma minus 1, T2 V4 gamma minus 1. So this equation arranged like this: T1 by T2 V4 by V1 gamma minus 1. So from 1 and 2 equation is V3 by V2 V4 by V1, and this equation arrange the V3 by V4 is equal to V2 by V1. So this equation number 3. So we know about this Q is equal to RT ln V2 by V1. In slide number 3, we can this equation right. So Q is equal to RT1 ln V2 by V1. So we know about this work done is Q1 minus Q2. So work done Q is equal to RT1 ln V2 by V1 and RT2 ln V3 by V4. So this is value for W. So we know about this efficiency is equal to W by Q. So we put this W is equal to this value, and the Q is equal to this value. So this equation is solved, then we will get the efficiency for the Carnot cycle. So the efficiency for the Carnot cycle, the T1 minus the efficiency for the Carnot cycle is the T1 minus T2 divided by the T1 is the efficiency for the Carnot cycle. Thank you.